Welcome to the Spoon Podcast, where we talk to the builders and makers on the front lines of the food tech revolution. I'm your host, Michael Wolf, and today's guest is longtime friend of the show, Scott Heimendinger, who I wanted to bring on because he's going to be at the Smart Kitchen Summit in just about 10 days or so. SKS Virtual, which is virtual. SKS Virtual, it's online. You can attend it no matter where you are in the world. And you're going to want to join us and listen to and connect with Scott and ask him questions because he is such an interesting person who always has his hands on building things. And we're in this interesting moment in the world where all the normal procedures and costs and ways of doing things are being turned on their head. And so I wanted to talk to him about that. So we get deep into that. And a lot of it revolves around a conversation we have about a podcast we just listened to, the Search Engine Podcast, an episode about that, about a maker, a builder that's trying to build something in America and the challenges of doing that. And so it's just a really interesting, timely conversation. So I encourage you to listen to it. Like I said, if you haven't already gotten your tickets to SKS, please do so now. Go to smartkitchensummit.com. Use the discount code podcast to get 15% off. You can join us, listen to Scott, ask him, other folks like Chris Young, Amy Taylor, Matthias Muchnik, questions, and interact with them. So it's going to be a lot of fun. So join us. Use discount code podcast for 15% off, and I hope to see you there. But for now, let's get to my conversation with Scott Heimendinger. All right, one of my favorite people to bring on the podcast to just talk in general, Scott Heimendinger. How you doing, man?
I'm doing well. How are you, Mike?
I'm doing great. We have SKS in just about a week and a half. You'll be in the first session with our good friend Kai Schaffner, who is the former CEO of Thermomix North America, and we'll just be talking about the state of the state. But I just want to catch up with you and record a podcast in advance of that because there's so many interesting things going on, so many podcasts we're listening to. And we were just talking in the pre-conversation about this podcast on Search Engine, which I'm a big fan of, PJ Vogt, longtime listener of his. And you just happen to listen to that same podcast.
I did. The episode we're referring to is Destin from Smarter Every Day, talking about the creation of the smarter scrubber, which, although, we talk about a lot of smart kitchen stuff, there's no, there's no circuitry or services or anything in this scrubber. It is a barbecue grill scrubber that he and a partner made, where the whole goal was to make the entire thing in the United States. And it caught my attention for a number of reasons. One, I'm a fan of his YouTube channel. I think he does really cool stuff, trying to get people excited about engineering and the types of challenges engineers have to overcome. But also, so my company is Seattle Ultrasonics. And although what I'm actually working on is still a secret, you can kind of guess that ultrasonics has something to do with it. And in talking about his background on the podcast, Destin mentions that his first job out of school was working as an intern at the Little Debbie factory, where part of his job was to tune and optimize ultrasonic cutting machines, these big industrial machines that they would use to portion their snacks or bars or brownies or whatever. And that is an area of technology that I've been studying for a couple of years. And so that totally got my attention. But that's an aside from what we're really talking about, which is this idea of manufacturing in the United States.
And that is such a challenge, but it's something I think every product maker, inventor, et cetera, in America is thinking of because of the craziness of the current environment. And no doubt, I just got an email from another friend of mine, Robin Liss, who's been living overseas, trying to figure out how she's going to shift her manufacturing from China to another country. So if you are making a piece of hardware today, you are spending a lot of time thinking about this. But manufacturing in the U.S. is a big challenge. And one of the things that I thought was interesting about this podcast is, and I kept thinking about, I need to tell my son to maybe think about doing this as a career, is just the lack of people who are working on tooling and kind of helping people set up manufacturing. And that seems like an area that's been a muscle, an area that's been completely hollowed out in America. Like it doesn't even hardly exist anymore.
No, it is basically gone. And for folks who aren't familiar with some of the terminology, when we talk about tooling, we're talking about the molds made for injection molded parts. So look around whatever room you're in, and there's a lot of stuff that's made out of plastics of one kind or another. And 99.99% of those plastics were injection molded. You heat the plastic up until it's liquid and you squirt it into a very precisely made mold. It very quickly hardens and it's shot out, and there you have your part. And the reason that we make so much stuff out of injection molded plastics is that it's very inexpensive. You're not using any extra material, but it's also super dimensionally accurate. So in other words, all the parts come out are totally identical
Exactly the
within
same.
very tight tolerance, and they fit together. And so it's the way stuff is made. But you can't, like, there is an art and a science to tooling design and to injection molding in general. I'm no expert, but my level of expertise and awareness has sort of climbed quite quickly over the last couple of years, since the product I'm working on is made from several injection molded parts as well.
Yeah.
And these tools are so important. They're so... on the balance sheet of a company that makes stuff, you will see their tooling listed because it is very costly to make and it's considered such an asset to the company. The problem that Destin ran into when he was trying to injection mold this very, actually quite simple part on his barbecue
I think
scrubber.
mainly the handle, right? Or no, was there parts of it?
Yeah. So I bought one of the smarter scrubbers right away because I thought the story was so cool and I wanted to see it. The handle,
of course you did.
Yeah, the handle itself is actually made from a rolled steel, sort of a flat piece of steel. That's
and he talked about that on the podcast. He stamped it on the podcast.
Yes, it was very cool and a great way to do that. But where that connects to the sort of the body of the scrubber is an injection molded plastic piece. And he wanted to have that piece made in the United States. And the first problem he ran into was that there are so few injection molding facilities in the US. This is not like a simple thing. These machines are huge, right? They're the size of like a Volkswagen bus for a small one. And you go to an injection molding factory. I've been to several in Asia, and there's like a Costco sized, floor of these machines, and they come in different shapes and sizes. Some of them do multi-shot. Some of them have, different pressures, how many tons of pressure they can generate. And some of them are roboticized and they're lined up, and that's what so you wouldn't just, like, if you're a company that wants to make a doodad, you wouldn't just go out and buy an injection molding machine and try to set this up from scratch. You would use a place that specializes in this.
And these are basically factories or big giant machines that make the machines that make the machines. Like it's the machines that will make the machines that make machines, essentially. So.
Yes. Yeah. So problem number one is that there are very few injection molding facilities left in the United States. And those that are left tend to be specialized in certain industries, like medical devices, for instance, where maybe there's import-export restrictions to the thing you're making. Or in the case of medical devices, the markup on the product is so big that you can afford to do it in the United States and not worry about getting your mold ripped off overseas or something like that. But then the second problem, which hadn't occurred to me, but is really cool in his telling of the story, is that he couldn't find. He finally found a factory that said, "Oh yeah, we can do your injection molding for you." And they said, "But the design and fabrication of the tool, your multi-part mold, that has to happen overseas because we don't have tooling designers here, and tooling fabrication." In principle, is something that you could just do on a beefy CNC machine, just a giant milling machine. In practice, no. There's it's really specialized techniques and tools and whatever to make this stuff. And so, so that's like a second barrier to entry. And this is really, I think, the meat of the problem is knowledge and expertise has been lost over the last couple of generations, that people who learn to design these tools, which have to be designed in very particular ways. You can't it's not like a 3D printer where kind of any shape can pop out of it. Things need to be able to flow and have input gates and venting ports and sliders for cavities. And there's a lot of thought that has to go into it. That knowledge has dried up in the US because it is just moved overseas. It's been cheaper to do, and so folks have not gone to school for that or taken up sort of tradesperson training for those things.
Yeah, I have so many thoughts on this, and I just think about how when I was in high school, I used to go to shop class, and that seems like that's disappeared. Like the whole kind of shop training class aspect of American high schools has largely disappeared. And then why is this not a key area of investment for Wall Street? Like it feels like this is just a golden opportunity. Maybe this is happening. Maybe there will be a startup that's going to say, hey, or like maybe it's a spin out of like I don't know, I'm just Boeing or someone and say, hey, we're going to be the tooling company for America or something. It just feels like there's such an opportunity here. And then strategically, how did America let this happen? We could spend a whole podcast season talking about this, I would imagine, but it's just such a big thing to let erode. It's crazy.
Absolutely. And it is not just tooling. Tooling and injection molding are a really good sort of single point example of the movement of these capabilities overseas. But even regular prototyping, milling of stuff, whatever, the cost to do the work in the US is so much greater than the cost to do the work overseas. I'll give you examples. So the project I'm working on, I have to make a bunch of prototype parts, and I have been for years. And sometimes these parts are plastics and things. Other times these parts need to be metal, and they have to be made by milling. Metal 3D printing is a thing. Its applications are not. You can't do a one-for-one swap just because of the way metal works. So I need to get these metal pieces milled. Small pieces, pretty simple geometry. Anybody who knows their way around a CNC or a CNC lathe would understand how to set up and make these parts. And it's not a lot of material. It's a small thing you can hold in your hand. I looked for quotes domestically for making these prototypes. There are websites out there that essentially are a clearinghouse for a bunch of small shops or larger, more automated shops in the US and abroad, where you basically upload your file and they do some real-time coding and give you pricing back. Separately, I did the same process for rapid prototyping services in China. In particular, these two companies I use called PCBWay and JLC PCB. They make electronics boards, and they're kind of unbeatable on price for that, but they also do 3D printing and metal milling and that kind of stuff. The price difference is 10x. There's not a hyperbole. 10x at a minimum for the parts made in the US versus the parts made overseas. And you might go, oh, okay, well, but then your lead time, right? You're going to save so much time that it's worth it. These parts in China, the turnaround time for that pricing is about 9 to 11 days. In the US, that 10x pricing is a little faster, but you're still talking about 6 to 10 days for that.
Negligible.
I contacted local shops here in Seattle. There are a couple of machine and metalworking shops, and I thought, well, I would like to be a good customer, right? Like I'd love to spend money locally, especially on shops that are doing this kind of stuff. And I know it's going to cost more, but maybe in this scenario with my simple parts, I'll just make it up on time, right? Everything's in a hurry. I can trade time for money, and that makes a lot of sense in certain scenarios to keep me unblocked. So I called up several of these shops and I explained the parts that I'm trying to make. And I said, look, I know this is going to be more expensive than what I'm doing in China, obviously, but maybe we can make this up on the time front. And they said, yeah, before we even got into real pricing, we were already above 10x. They said, so I said, but what are our turnaround time? They said, well, it depends how busy we are, but 1 to 6 weeks.
Which is
so we're going to
slower than China.
Slower and more expensive.
10x the price.
So this is sort of a microcosm of this problem that even if you want to spend your dollars in the United States to have physical stuff made, it is dramatically uncompetitive. So, you know what I ended up doing to solve this problem? I bought a CNC machine. It is blurry behind me because what's going on behind me is still secret. But I bought a desktop CNC machine that is just barely but capable of milling stainless steel. And I broke even probably in the first 20 parts that I made on the machine. And I'm doing it myself because I don't charge myself a labor rate for this. And that is the way to get it. I should, right? That is the way to get it cheap and fast. It's sort of the only way is to bring it in house. But if I were paying somebody else to run the machine for me at domestic machinist hourly wages, again, we would be in non-competitive territory with the costs to do these things overseas. And the folks overseas have tremendous experience and specialization and skill and local supply chains, and it's just not even close.
What's so interesting is I was following the maker movement pretty closely, 15 years ago, talking to like Ray Pettis, the founder of like MakerBot and all the stuff that was happening. And there was like a lot of excitement about it. And so I feel like there's like a weird thing that happened where we talked about, hey, let's start making stuff and teach our kids to make stuff. But at the same time, America's ability to make stuff at scale really just kind of disappeared and went up in smoke.
It totally did. And look, I'm of two minds about this. On the one hand, like I love physically making stuff. I love being hands-on. You mentioned that school shop programs seem to be shutting down. That makes me so sad because some of my favorite classes in high school were doing sort of technical theater, which is where I learned to weld for the first time, and and doing wiring and all this kind of stuff I loved, and sort of sculpture class, learning to use a bandsaw and a drill press and all that kind of stuff. When I worked at Microsoft, I like sweet talked my way into their hardware prototyping lab so I could use their laser to carve pumpkins and cut seaweed. And I love being hands-on. I wish more folks in the United States prioritized the hands-on making of stuff, and I wish that we hadn't eroded away these capabilities. That's on one hand. On the other hand, I am essentially a solopreneur. And the fact that armed with basically just a laptop, I can design circuit boards, 3D models of assemblies that are made of plastic and metal and whatever, and toss these files over the fence to services that will make them in high quality at super high speed for super low cost in volume 1 or 2 or 5 or 20 or 20,000. Like that's amazing, right? The knowledge work is my responsibility, and it is almost point and click to have these things prototyped, if not mass produced. And that's an incredible boon to being, a scrappy solopreneur kind of a thing. These services weren't available not that long ago. Getting a PC board, getting electronics made was like a really steep hill to climb, and now it's like practically free in a Cracker Jack box. So that these things simultaneously, I both believe are true, but it is sad that the disparity is so great that it's not like, oh, I can pay 30% more, 50% more, or even 100% more for an American option. It's like
nothing.
It's 10x at least.
And it's not like taking a product to scale through China is cheap, because how many countless Kickstarter projects have we seen go to die after, hitting their target? You get your $200,000, you get your 1,000 backers, and then you're able to take your 3D printed device, go to China, and then it just dies because as you try to go from prototype and PowerPoint to mass production, super expensive.
So
I couldn't imagine. And imagine trying to do that in America. It's impossible for like a small hardware startup.
I don't think folks who are outside of engineering and manufacturing realize how expensive it is to make even cheap stuff. Like
Yeah.
uh, anything made of that has plastic parts, or whatever. y- I will be shocked if the tooling for those parts is less than $25,000. For anything that's got some level of higher complexity, fit, finish, size, whatever, it is really not difficult to spend $100,000 on the tooling. That's a check that you write to make the tool that lets you produce these parts. That does not include the cost of actually producing the parts. And something, fancy things are a lot more than that.
Yeah.
Um, and I don't think folks realize the level of expense required. And those are numbers for overseas. That's China, that's Malaysia, that's Vietnam. That's numbers for there. Trying to do that here, uh, like I said, multiply everything. And why would anybody funding your startup want you to spend 10x to get the same thing unless this was an issue of
National
export
security or
restrictions,
something.
national
Yeah.
security, that kind of a thing? Yeah.
And there's a whole conversation to be had about, we talked about shop, but just the going away of tradesmen. And so, I mean, I love what you do. I admire the ability of you to design the stuff in CAD and stuff. But then there's like, and a lot of people who like making stuff oftentimes will go into like these digital forward kind of careers, like making software, etc. But that part of that podcast in the interview was like this old guy who had this tooling company. It has a guy who's working for him who eventually wants to take over the business. But when they asked him what's happened to all his peers, they said they couldn't find anyone to take over the business. So like that is a trade, making tooling, that for some reason isn't all that sexy, but probably could be really lucrative if you could take over those types of businesses. So I don't know. It just feels like it's like a missed opportunity or something.
Do you've got kids who are sort of in the generation that's been emerging in the workforce. Do you get any sense through them or by just sort of being exposed more to that generation that there is a renewed interest in doing
Mm,
physical things as opposed to like just
no,
doing software or crypto or
I
whatever?
mean, I think there's a lot of younger kids in that generation who want to, let's just start a YouTube channel or whatever. I'm exaggerating maybe, but there are a lot of people like, hey, let's be a digital creator. My son, who you knew, was involved in the robotics program, and it was something that ultimately I thought changed his life. And there were some really great mentors in that program who worked at Boeing, who worked at some of these amazing companies around the Pacific Northwest that actually build things. And then they came in and taught him how to use CNC machines and 3D printers and do wiring and circuit boards. And they made amazing robots. And I never thought watching robots battle it out on a field would be amazing, but I thought it was more entertaining than going to football games. I loved it. So some of these kids that came out of these, for example, the first program, which I think is a really great program, probably did, but I still think a small majority of them ever really take these types of careers up because they may be going into engineering and they go into software programming and they're using digital tools and they still think trades, maybe like having a trade like tooling is probably pretty boring. I can't speak for a generation, but I
Yeah.
don't know. It feels like not a lot.
So I graduated college in 2005. So I was in college when the dot-com bubble collapsed. For those listeners old enough to remember the dot-com bubble, um, and then with enough time for things to kind of rebuild some steam. So when I graduated college, companies like Microsoft, IBM, the consulting firms, Accenture and Ernst and Young and all of them, they were basically backing up dump trucks to the technical colleges, to colleges that had computer science and information systems programs, and they were just loading up graduates and giving them good, high-paying jobs with signing bonuses and all that kind of stuff. And that continued for at least 10 years, maybe more, after I graduated. Now, tech companies have been in these layoff spirals.
Microsoft laying off thousands
9,000
every
people.
couple of months.
Yeah. Just shedding talent. There's an argument that, which I think is valid, that AI is driving a lot of that. I use AI for software development almost every day, and it is a sort of a force multiplier on how much and how quickly I can write software. And so there's less demand for software developers. I think that's a valid argument. There's also another argument that says changes to the tax code and the ability to deduct the salaries you're paying to engineers as part of the R&D tax credit, which has gone away or has changed substantially in the software industry. Basically, it is part of that also. But the net is that there is a massive contraction that's happened in how lucrative it is to go into software development as a career. Meanwhile, welders, plumbers, electricians, framers, those jobs are pretty highly paid. They're strongly in demand, and they're much more aligned with trades than something else. So I don't know if this shift is going to be enough that it's going to encourage, young folks who are, looking at what to do after high school graduation to enter more hands-on fields, but it might.
Yeah, that's a great point. I think the idea of, for the past 20 years, the advice has been, if you learn computer science, you're basically guaranteeing yourself like a very successful, lucrative career. Who knows, maybe you'll go for a startup and you'll get stock options. And that's been the dream. We live in Seattle. Like, we've all heard the Bill Gates story 1,000 times. And then how many friends have you had that went to work for startups and gotten options? And like, it's just happened over and over across America. And I've seen a little bit on social, people bemoaning like, hey, if we've been giving everyone the wrong advice, like telling them to go into computer science, and now that AI is eating up those jobs, I don't know. But I do think you're right. Like, I think I've had a couple friends, kids who have chosen not to necessarily go to college, but learn how to become an electrician. Because I don't think like AI is going to take over installing like electrical junction boxes in our homes anytime soon. Like, I feel like, and by the way, have you ever gotten a quote from an electrician lately? It's really, really high.
Yeah, this is why
there's money there.
Self-wiring, not,
yeah.
But who knows? If we do have this sort of, if there is a renewed interest in doing things and the economics change enough that we've got folks who are picking up the mantle of tooling design, and we've got companies who are reopening injection molding factories, maybe we'll come full circle to the advice from the movie The Graduate, which is that the hot new field here could be plastics once again.
I mean, I know a lot of venture capitalists. Mainly I've known them in the world of food and food tech, and like the people who have been behind investments in all proteins and stuff. And like, I have to, and by the way, hardware has been a space that most of them avoid, especially consumer hardware. Consumer hardware is a death knell now, by and large, as an investor. But gosh, if I was an investor, I would want to be hearing the pitch for building the tooling factory of the future. You know what I mean? Like, I feel like someone's got to be investing in that space. Like, that's got to be, if I'm hearing pitches about building, hey, we're going to be the next great tooling and kind of manufacturing hub, like, that's interesting to me.
And I think those pitches will come, but honestly, I think that pitch is going to be, we're building the next great tooling factory in America, and it will be staffed entirely by robots.
Probably, you're right. You're probably right, which makes me kind of sad. Well, that's super interesting. I feel like we can have a whole series of podcasts about that, but I do want to talk to you about why I have you on here, about what you're seeing and excited about in the world of kitchen tech, in the world of smart kitchen or whatever. It's funny. I just wrote a piece yesterday about Thermomix making deals with 2 AI companies and 2 robotics companies. Vorwerk has a deal with NVIDIA, and they're using NVIDIA's robotics platform to basically develop prototypes for cooking in the home.
Huh.
And then Vorwerk is partnering with one of the biggest robotics startups in Germany. And they announced kind of their partnerships at this big German trade show around robotics. And so I don't know. I've been following home cooking robots for a while. I remember like even back in 10 years ago when Moli debuted their cooking robot and won Best of CS in Taiwan. There's been no home runs. No one's really kind of hit it out of the park. We still haven't seen the big humanoid cooking robot that essentially becomes Rosie Robot. But I don't know. Maybe it's going to be someone like Vorwerk who like has had a lot of success with Thermomix, and which I think Thermomix can be argued as one of the most successful products in terms of cooking automation ever.
I couldn't believe when I looked up Thermomix's numbers, or their parent company revenue numbers, how big it was. I saw I was scrolling my Instagram feed as you do, and I saw this video of a huge auditorium, right? Like it looked like an Apple launch event, and up on the floor to ceiling 40-foot tall screen was a video of the newest model, and
the TM7.
Everybody in the crowd loses their fucking mind. They're like screaming and they're going crazy. And my first thought was like, oh, this is really cute. Like somebody who's a fan like superimposed this video on like an Apple or an Nvidia sales event or whatever as like a funny video. And then I saw it from another angle and I realized it was real. And I looked up like, how big is this company? And I was gobsmacked by the numbers that they do. So yeah, you're right.
There's millions and millions of Thermomixes in the field, and they've been around since the 60s.
It's wildly successful. I don't know that I'm a better prognosticator than anybody when it comes to robots in the kitchen, even though I have I have more robots than the average bear. There's a robot arm over my shoulder in my office here with a knife strapped to it. But we saw this real epoch change with LLMs, right? This real breakthrough capability in what you could do with LLMs that spawned 1,000, 10,000 new startups that are doing a thing where the thing they're doing is putting a pretty lightweight wrapper around somebody else's model to make it be a little more useful or a little more polished for some specific thing. I feel like that moment is arriving for robotics. For a long time, the challenge in robotics has not been how do you make a arm move precisely, or how do you have enough power or battery capacity or whatever. The problem has been the software. It is how do you give it instructions? How do you tell it, pick up the soda can and put it in the trash? Or more broadly, clean my kitchen, please, and have it understand all the subtasks and all the planning and all the stuff that needs to happen with that. But lots of folks, including Google, I mentioned just because I'm aware of their work, are working on exactly this. And I think we will see the breakthrough moment come. I don't know if it's in the next year or 5 years or 10, as this rolling future of kitchen automation tends to just kind of go right out to the horizon. But personally, I can't wait. I want to have the robot bartender from Passengers wearing a little vest, standing in my kitchen, polishing the countertop, and waiting to mix me a Manhattan whenever I emerge from my office at the end of the day.
By the way, have you started watching Murderbot?
Not yet. It's on my list.
It's about the robot who basically figures out how to override his governor and decides he starts to call himself Murderbot and just wishfully thinks of murdering all the people around him. Anyway,
robot can hear you.
Yeah, do not tell your robot arm with a knife. By the way, take the knife out of the robot arm's hand because, gosh darn it, that's just tempting fate, Scott.
I'm very aware of just how far he can reach.
So, I agree with you. I mean, Jensen Huang at CS this year said that this is the year of physical AI, and it does feel like we're at a moment. I mean, I was at the Culinary Institute of America, I think in 2018, when Sony was announcing and talking about their effort to make cooking robots. And there's always been a big push out of Japan, quite honestly, to think about how you can use robotics to help people age in place. And so that was probably big motivation for why Sony started doing that. Well, they've largely abandoned it. They made a really cool scissor reel showing off this cool futuristic robot. There's not a lot going on there. And Sony has been historically one of the world leaders in building robots with Aibo, for example. I mean, that was like a pretty seminal robot in the world.
Yes.
And if
Yeah.
they gave up on it, I feel like, gosh, dang.
Well,
Not that they have completely, because we
yeah.
wrote about earlier this year or last year about their Roku Shoku efforts to take human movements and replicate that with automation robots. So they're definitely doing some cool stuff. But I feel like now with the advancements in software, we are at a moment.
I I think we are, and I think that being a um, cooking robotics company, whether we were talking about something in a home environment or in a commercial setting, um, like almost no cooking robotics company, I think, is going to make their own hardware at all, or like
Hmm.
very minimally. You know, they'll make end
Okay.
effectors, they'll make the spatula holder, they'll make
Okay.
the attachment for a thermal camera in the way that almost no companies who are an AI first company actually make their own foundational models. The foundational models are enormous and require sucking up the whole internet and running it through billions of dollars worth of compute. And there are only a couple of companies on Earth that can do that. But now the models are basically free and available and easy to replicate, DeepSeek, and very easy to layer on top of. In the same way, you're familiar with Artly, the coffee robot
Yep.
company that's got the coffee
In
shop?
Seattle.
Yeah, they're in Seattle. I take out of town guests to their little cafe, which is a block away from me. It's very cool. They don't make their own robots. They're using Universal Robots arms because the interesting part is not moving around in 3D space with a portafilter. The interesting part is sewing the pieces together to knowing, like, here's where the coffee comes out, and here's how to insert the thing, and here's how to check with the camera to make sure there's actually milk in the frother. And so, in a sense, I feel bad for all these companies who have been painstakingly paving the way for cooking robots by doing a lot of the hard
Mm-hmm.
part, the hardware and the software together. When I think we experience this upcoming sea change where you buy off the shelf hardware. There's an Instagram account I follow that is $4,000 cobots in China that can do everything you want, from powder coating a fence to welding to flipping burgers. I'm sure you buy or get for free or license the foundational model, and then you put a natural language interface on top of it. You say, hey, here's some cameras that's on the robot, this one's on the ceiling, I want to make burgers, and it figures out the steps for you. And the thing you're building as a company is that last thin little layer of glaze on top of the hard parts.
Yeah, and if you can figure out how to monetize it, and that's why companies like Amazon, I think they own iRobot. They have
I
Ring.
think so.
They own the biggest cloud company in the world with AWS. They're the ones that are going to try and suck up all the money, but hopefully they'll leave some space for some of the innovators to that last service layer. And maybe it's the brands, right? Maybe it's the Electroluxes or the Thermomixes of the world that have millions of customers that enjoy their brand, and they'll partner up with these guys and take their culinary brand and create something new.
And or these companies will realize that there's a moment for a new generation of their products to be robot ready. So the Artly robot, you watch it make coffee. It's making coffee on a La Marzocco GS3 machine and a regular grinder, and they've had to like 3D print and Frankenstein on grips and handles and places for the robot to push the buttons, whatever. I don't really want the robot to struggle with turning the knob on my gas stove, right? I kind of
No,
like
no,
the
no.
robot ready version of that stove where it just like plugs in a little dongle or
Yeah,
communicates with
yeah.
it wirelessly and, takes and you don't have to worry about the clunkiness of a human interface. So maybe that's what we'll see in a next generation of stuff, is going from, manual transmission, human only, to self-driving ready.
Yeah, the overzealous, overstrong robot gripper that pulls off the gas knob after turning it on. Like, you don't want that
Right.
to happen. You want optimization there.
Yeah.
So we talked about robotics and the consumer kitchen. What else are you seeing? I just had a prep call for a panel we're doing about the future of food storage. And we had Tal Lapidat, who's the CEO of a company called Silo. Took them 10 years to get their future next generation Tupperware to market, and I'm so glad they did, because like I thought they weren't going to make it, but I backed them on Kickstarter like 7 or 8 years ago, and I have the box sitting next to me. I got to actually try it out, but I think that's a category I'd love to see more innovation in terms of like, hey, how can we store our food? And then like tell someone taking a swing at building a new fridge. The guy who's also going to be on that is the founder, a CEO of Rocco. It's kind of a smart beverage fridge. So, are you seeing anything interesting there? Do you think that's a category that we'll see some kind of reinvention in?
I think it's a hugely important category, especially as we're all aware, food costs have been skyrocketing
Mm-hmm.
in the US.
Mm-hmm.
Food waste has been a problem essentially forever. Um, but those two things compounding together means that having better food storage, where we're talking about sort of extending shelf life of fresh foods, is more important than ever. It's also an area, though, where I see some of the greatest potential for breakthroughs coming from more foundational research. So
Mm.
there's a company, maybe you'll remember, I think they're called Peel or Appeal.
Appeal, yeah.
Yeah. That makes a coating for produce that helps prevent your produce from turning bad as quickly. That's a really cool material science and chemistry based approach to that problem that requires some foundational science. We see other companies attacking this from a different space. Hey, can we essentially put an air freshener or a filtration system in the fridge that will eat up some of the bacteria that may be landing on stuff and start leading to spoilage? But you can imagine that approach can turn the dial a little bit, but may not get you to 2 or 3 or 5x the shelf life as
Mm.
something that is just a much more scientifically deep approach to that problem. Sadly, this is not a great time for investments in those
No.
core foundational sciences. This is the type of stuff that would build on scientific research funded by NIH or other government grants. And as we know, that's all drying up.
That's
But
drying up. I've had friends, you probably have had friends that seen their grants just vaporize after kind of planning the next few years around it, which is really, really sad. But I do think Appeal is really interesting to me in the misinformation driven world we're living in. Like, I know that they had a bad moment on social media when everyone's all these kind of semi pseudo educated people were freaking out about this chemical that's being put on their avocados, which realistically is probably harmless to them. But you can see how people would start to freak out about that. So that was one problem that they had. I think they've overcome it. But I think you're right. Foundational science, things like CRISPR, for example, tweaking the gene to
yeah,
take out the part that ages it faster, so where food just lasts longer. But food waste reduction is such a complex puzzle of human behavior change, core science, interesting gadgets like making our fridges smarter. Just so many different parts to it that makes it
yeah.
so complex. But you're right. The rising cost of food going up might drive all this, because gosh, food is getting expensive.
My solution to it here is pretty low tech and not without its problems. Because I've been cooking sous vide for a very long time, I've got a chamber vacuum sealer.
Have you heard of these things called sous vide circulars? Have you ever heard of those?
I have.
Oh wait, you invented it. Oh,
Yeah,
okay.
sounds fun. No, I've got a chamber vacuum sealer, like the type that you would see, at a butcher or a deli or whatever. Not just the food saver edge sealer, but the type that is this. I mean, it's a 100-pound giant thing that takes up a bunch of space in a front closet that I added an outlet to. So it's not for everybody. You wouldn't want it on your counter full time. But what it does really well is reduce the amount of space that anything you want to store takes up to basically its minimum, right? Because you
Mm.
put it in a bag, it sucks all the air out of the environment, it seals the bag, which gets compressed around it. So if I've got leftover soup or pasta sauce, or literally there is vacuum packed leftover pizza in my freezer right now. It
Of
takes up
course there is.
the absolute minimum volume possible. And because you're removing just almost all of the atmosphere from around the food, things last for a really, really, really long time under those conditions. The problem, of course, is you're using lots of plastic bags, which people don't like for environmental reasons.
Yeah,
Some people are wary about that for sort of chemical reasons. I don't love additional plastic waste, but we don't
No.
have a suitable alternative for something like that right now.
The silo system is their kind of big thing is it's vacuum sealing. So it's vacuum sealing in reusable containers. And so that kind of along the same point, like they're not wasting a bunch of plastic. And that was their key idea. And what was interesting is like you talked about today, how I don't know if I should mention this. Maybe they're basically trying to add their own audio interface. Right now they're Alexa, but they want to basically do their own silo voice interface enabled by these large language models. So these large language models can enable folks like a startup to spin up their own voice interface, which I think is interesting.
Huh. That is interesting. Yeah, we'll see how integrated that is. I mean, our home assistants are still arguably sort of one generation behind in Alexa and Google Home and whatever are not fully brought on to the new version of the world where it's basically the movie Her, but sitting on a device with a screen in your kitchen. But some of these, what you might call micro app scenarios, set a timer, convert tablespoons to grams of flour, or like those things are still very popular kitchen scenarios because they're simple and ubiquitous. And so I don't know what Silo has in mind, but if it's something like that, maybe they'll get traction.
What I like talking to you about is like all your crazy innovation that you do, but you do have a foundation of like actually having computer science and engineering backgrounds. I just was reading a horror story of there's so many AI stories out there. And like, there's like a lot of people who aren't necessarily computer science engineers who are trying to do what they call vibe coding now, which we've all heard about. But it's funny to hear about how some of these vibe coders are getting their stuff hacked because they don't really know how to check for vulnerabilities. So like getting back to the idea of like actually having the knowledge and being able to kind of know what's happening in addition to just creating stuff with AI is so important. But I love the fact that you have that foundation. So it's always fun to talk to you, Scott.
It's a pleasure to chat with you, Mike. I could do this all day.
Well, that was a great conversation. If you are someone who's building a product, trying to scale a product, I hope you found that valuable. And Scott will be at smartkitchensummit.com in just about 11 days. If you want to talk to him, just go to smartkitchensummit.com, get your ticket, and be there. Use the discount code podcast for 15% off. All right, folks, that's it for now. We'll talk to you next week.
If you enjoyed this episode, why not share it with a friend? And don't forget to give us a 5-star review. You'll find more content like this on the spoon.tech/podcasts.